All right, so solving rational equations. Let's look at that first example right there. Now, there technically are two methods that you can use to solve rational equations. I'm going to show you what I consider to be the easier of the two methods. And it's easier for several reasons, but we're going to go with just one of these two methods. So we need to identify what the least common denominator is when we're looking at the entire equation. Now, we're not doing that for the purpose of getting the least common denominator. Okay, we're not going to combine fractions here or combine rational expressions. What we're going to do is we are going to eliminate all of the denominators. Okay, we're going to eliminate all of the denominators. So LCD, if we look at our denominators, we've got 5p in the first one, we've got p in the second one. Don't overlook this last fraction. It doesn't have a denominator. For practice and for recognizing it, go ahead and put it over 1. I know it's redundant, but it will help you later on down the road. So our least common denominator is 5p. Okay, what do they all have in common? But we want to keep it as small as possible. Now, here's another reason why I think this is the easier method to use, because you can know whether you actually got the LCD or not. We are trying to eliminate the denominators. So once we identify the LCD, we're going to go through and multiply just the numerator of each of each term, okay, of each term in our equation here. We're going to multiply by the LCD. If it was indeed the LCD, we are going to be able to eliminate or cancel any denominators that we had in the problem. So when we look at that first expression, you know that in a fraction, if you have something in the numerator and in the denominator, you can cancel it. So we can cancel the 5, we can cancel the p. What are we left with? We are left with the 1. I suggest you circle it or write it down immediately, particularly when it's a 1. You don't want to lose that in the process because just a 1 can make a big difference in these equations. When we move to the other side of the equals, the p cancels there, and that's all that cancels. So we've got 2 times 5, which is 10. Don't lose that minus. Nothing cancels in that last expression, so we have 1 times 5p, which is, of course, just 5p. So our denominators are gone. We didn't necessarily add anything extra. What I mean by that is you don't need both of these p's. 5 times p and the p by itself, those p's overlap. Now we'll look at in a minute where they don't overlap, but when they look like that, they're considered overlap. Now we just have a linear equation that we need to solve. Same steps you've been doing for years now. Subtract the 10 from both sides. 1 minus 10 is negative 9. That's equal to negative 5p. Divide both sides by negative 5. 9 over 5 does not reduce, but you got a negative divided by a negative. So that becomes a negative 9 over 5p. Now, I highly suggest you always check your answer. It's an equation. There is no reason why you should not check your answer. I would suggest storing that as x. Don't try and plug in a fraction into another fraction. It gets complicated. Store that as x. 1 over, now be careful when you plug this in. If there's more than one number, variable, anything in the numerator or in the denominator, you must put parentheses around it. So I have to put parentheses around that 5x in order for it to give me the correct number. Then on the other side of the equation, we have 2 over x, no parentheses necessary there, minus 1. The left side equals the right side, so we're good to go. 9 over 5 is indeed our answer. All right, let's look at the second one. We have 4 over x squared minus 1 over 5x is equal to 4 over 5x squared. So when we don't have any missing denominators here, so that's good. Identifying our LCD, I notice that I've got x squared in 2 of my denominators. That x in the middle denominator is absorbed in that x squared. So I don't need x squared and x. I just need x, and then of course I need the 5. 5x squared is my LCD. If you're struggling with figuring out the LCD, ask yourself, what is the smallest thing that I can multiply each of these by and make my denominators go away in each case? So if we multiply by the 5x squared in all of our numerators, in the first case, the x squared cancels. We're left with 5 times 4, so that's 20. This is another subtraction. In the second one, the 5's cancel. X squared over x is just x. So I don't know how you want to express that, but that's kind of what I do. I'll mark out the exponent of 2, and I mark out the x in the bottom. So 1 times x is x. On the other side, the 5's cancel, the x squares cancel.
At this time, freshman Hill 3B, please report to the media center. Thank you.
And we're left with 4. Again, now it's just a linear equation, trying to get the variable by itself, subtract 20 from both sides. We get negative 16, but it's negative x, so we divide by negative 1 to make that a positive 16. Before I circle it, I'm going to check it. Store it as x, even though it's not a fraction, store it as x. It's just a whole lot easier to plug it in. 4 over x squared, no parentheses necessary, minus 1 over, parentheses are necessary here, 1 over 5x. Right side, 4 over 5x squared, 5x squared in parentheses. Same decimals, answer checks out. 16 is the correct answer.